All right, so at the end of the day Friday, or at least at the end of the class period, we had defined our variables, but then we kind of stopped there. We had circled and underlined all the important information that we had found. How can I use my three variables and the very first piece of information I have to write an equation? How can I use the three variables that we have and the very first piece of information that we circled to write an equation? Absolutely. X plus y plus z, the amounts invested in the high risk, the low risk, and the government bonds has to add up to the total amount that they have to invest to begin with, which is $750,000. All right. So we've got our first equation. You're welcome. How can I write another equation?
We got to do something with the percents, right?
We got to do something with the percents.
So, would it be something like the last question that we did, or the last problem, where it was like something like 0.04 or whatever.
Okay.
Times 750,000 minus y or whatever. Like, you know what I'm talking about?
I like the way you're thinking. So tell me, each of these percents, what are the different percents that we have?
0.12, 0.08, 0.04.
Yeah, 12% or 0.12, 8% or 0.08, and 4% or 0.04, right? That 0.12%, sorry, not 0.12%, 0.12 or 12% goes with which type of investment? High risk. So I could do 0.12 times X, because that's my high risk account, right? What would I find by doing 0.12 times X? How much the interest is after just 1 year, right? Because we're just talking about 1 year right here. So this would be interest at 1 year. Can I take this idea and apply it to the other types of accounts? Okay, so what would that look like then?
Plus 0.08y plus 0.04z.
Yes, plus 0.08y plus 0.04z.
Wouldn't that be 70,000?
70,000. Why would it be 70,000? You're absolutely correct.
Because that's how much they want their money that they have to go up.
Yes. So I'm going to scoot this down just a little bit. This is interest at 1 year. This one is high risk. Oops. This one is low risk. This one is bonds. And this one is total. Just in case anybody's not fully following along here, can somebody explain to me how we got the 70,000 from the numbers that were given? Subtract it, yes. So we would do 820,000 minus that initial investment of 750,000 And that's where the 70,000 came from. Before I move on, I'm just curious if anybody could figure out how I could write the first part of this equation slightly differently so that I wouldn't have to do that subtraction. I could just set it equal to 820,000. Yep, I'll repeat my question. There's something very slight that I could change about the left-hand side of this equation with the 0.12 and the 0.08 and the 0.04. Something very small that I could change over there so that I could set it equal to 820,000.
Would you put a 1 in front of the number?
Put a 1 in front of each of those, because that would be my initial investment plus the interest, my initial investment plus the interest, my initial investment plus the interest. So you could do 1.12, 1.08, and 1.04 is equal to that grand total at the end of a year. You can do it either way. All right, so we've got 2 equations so far. How many unknown things do we have? 3. I've got 1 equation here, I've got 1 equation here. I'm going to need a third equation, right? What other information do we have to work with that I could write a third equation with?
Twice as much.
Twice as much. Talk to me about twice as much.
That's 2 times.
2 times. 2 times what?
The low risk stock.
2 times the low risk or 2 times the high risk? I heard somebody say X, that's why I'm asking.
And low risk stock hasn't risk.
The low risk stock has
Twice as much as high risk.
twice as much as the high risk. So I'm going to write down what I was hearing at first, which was to write it like this. If I write it like that, which one has more money in it? X has more money in it. What does X mean? High risk. Does the high risk account have more money in it? No. So what do I need to do to fix this? Switch the X and the Y around. Now which account has more money in it? Y, which is my low risk account. And that's what we said we wanted, right? The low risk account should have more money in it than the high risk account does. How can I use this third equation in a way that will help me simplify the 2 up above it?
You can substitute in 2x for y.
We can substitute in 2x anywhere we see a y.
Couldn't you also substitute in X if you saw for that?
Yeah, you would be substituting in y over 2 if you wanted to substitute in the place of x. Yes, you could absolutely do that, because that's saying that the high risk account has half as much as the low risk account, which is true. All right, so I'm going to have x plus, and then I'm going to do my substitution here with 2x plus z equals 750,000. And then I'm going to do a substitution down below as well. I have 0.12x plus 0.08 times 2x plus 0.04z equals 70,000. What do I get when I simplify the one that doesn't have decimals? Yep. I get 3x plus z equals 750,000. What about the one with decimals? Yes. We're going to have 0.28x, because when I multiply the 0.8 and the 2, I get 0.16, and then I combine that with the 0.12. So 0.28x plus 0.04z equals 70,000. We can pick now between substitution or elimination. What would you guys like to use? Substitution? So tell me what we're going to substitute if we use substitution.
We could substitute from Z for 750,000 minus 3.
Yes. We can take this idea right here, and I can have Z equals 750,000 minus 3x So now down here below, I'm going to have 0.28x plus 0.04 times 750,000 minus 3x equals 70,000. What do we do from there? Distribute. So I have 0.28x plus what? How much? 30,000. Minus, that's what, 0.12x equals 70,000. I'm going to combine my like terms together. And at the same time, I'm going to subtract 30,000 from both sides. .28x minus 0.12x leaves me with 0.16x equals 40,000. Excuse me. Divide both sides by 0.16. And I get that x is what? 250,000. So here's my high risk. How much in low risk? 500,000. And you got there by doing what? Yes. 2x equals y. So 500,000 in my low risk. How much in bonds? 0 in bonds. Why?
Because 250,000 plus 500,000 is
Yep. 250,000 plus 500,000 already adds up to that total initial investment that they have. They've got no more money to invest, so they're not going to put anything in bonds. So far, so good? Okay. Gavin, you look like confused and slightly brain dead at this. All right. I am more than happy to take any questions off the review. I know that we already had a request for number 2. I had an emailed request over the weekend for problem number 2, so I'll start there. And then there's one more addendum that I want to make. Do you guys remember how on number 21 I told you you didn't need to find the range? 25, same thing. 25, you do not need to find the range. And if you guys want to hear a funny story about why, I'm happy to explain, but it ended with a very long conversation with a former professor of mine who has 2 doctorate degrees. So I was like, I don't think you can do this just with the information given. And he's like, yeah, no, you can't. here's the proof for y. It's like, okay, I'm not crazy.
Which one are we doing?
We're doing number 2 right now, but on number 25, you do not need to find the range. Yes, sir.
Can we also do 1B?
1b, absolutely. Let me get that pulled up here. That is not what I told you to do. Thank you for playing.
That's your
Where did it go? There it is. Okay. There we are. So we'll start with 1b and then we'll do number 2. Let's see if I can fit all of it up on the screen at once. Nope, but I tried. For all of the problems in number 1, these are all quadratic type. Every single last one of these is a quadratic type problem. What do we use for quadratic type? U. So we're going to use U-Substitution. So what should I let U equal over here on part B? Yes. E to the 4x. When I do that, I would have just a 1u right here. Here, I would have a 2 out in front. E to the 4x times 2, or sorry, not times 2, but squared to the second power, would give me e to the 8x. Because remember, when you have a power to a power like this, you multiply those together. So I would have u squared right here. You guys okay with that? So now I need to factor this so that I can find what u is. So I need 2 numbers that when I multiply them, I get -2, but when I add them, I get a +1. 2 and -1. So 2u squared plus 2u minus u minus 1 equals 0. I'm going to set up my groups. What can I take out of my first group? 2u. What would that leave me with? U plus 1. What can I take out of my second group? -1. And that would leave me with u plus 1 equals 0. You're welcome to use a box. I do grouping on here just because we've done other problems with grouping. And usually, honestly, I don't make the box just because I don't have a lot of space to work with. 2u minus 1 and u plus 1. So what are my 2 values for u? -1 and 1/2. Am I done? Because what is the goal of the problem? Not to find e. E is an established value. To find x. So I'm going to take what we let u equal and I'm going to substitute it back in. So I have e to the 4x equals 1/2 and e to the 4x equals -1. Is either of those problematic? Second one, why?
Because when you put it into the logarithmic form of argument, we have.
Yep. When we put this into logarithmic form, I have the natural log of -1 equals 4x, and the argument can't be negative. So this one right here is extraneous. Does the first one cause a problem? Nope. I would have natural log of 1/2 equals 4x, and then divide both sides by 4. I made it cross out with my x. We get that x is about how big? Yes. Negative 0.173. So there's our approximate solution. Here's our exact solution. What questions do you guys have before I go on to number 2? Yes, sir.
Can we just leave it in the exact form? Do we have, or do we have to put both answers?
Depending on the directions on the exam, if the directions aren't clear, you're welcome to ask, but if the directions aren't clear, I'm fine with exact form. Because if you can write it down in its exact form, all you do from there is pop it in the calculator. Any other questions about number 1? All the rest of the problems in number 1 are quadratic type like this one. You just need to figure out what u is going to equal in order to move forward. Yes, ma'am.
So just for D, what would U equal? Like, would it be E to the X?
Yes. Here's why. Let me rewrite this in a slightly different form and see if it makes more sense. So I would have e to the x plus, when I have e to the negative x, that's the same as having e to the x on bottom, right? And then equals 8. Even doing quadratic type, I can't have that piece in the denominator. So how would I get it out of the denominator? How can I get anything out of a denominator? Multiply everything by whatever my denominator is. Since I have an equation, I could multiply this whole thing through by e to the x. What happens if I multiply e to the x and e to the x? Yes. Not e to the x squared, but e to the 2x. Because remember, you add those powers. If you multiply the same base, you add the powers together. This would just become plus 7, right? What would I have after the equal sign? Eight e to the x. And so then here, let u equal e to the x. Let me just write this down clearly. E to the x times e to the x. We're going to add those two together. And that's how we get down here. So far, so good? What would you let u equal on part A? Radical x.
Can't you rewrite that?
Rewrite it how?
3 to the 1/2 x.
You could write it as 3 to the 1/2 x. Or sorry, not 1/2 x, or 3x to the 1/2. Sorry. You could rewrite it like that. But then you would still let u equal x to the 1/2. Because if you did x to the 1/2 squared, you multiply those two powers together, and that would give you just x. Does that make sense? Okay. Once we figure out what we're letting u equal, the quadratic type problems should be pretty simple and straightforward from there. It's just figuring out what you need your substitution to be. All right, number 2. I really like this one. I'm not going to lie. Because it gives you a little bit of freedom to come up with some stuff. There's a million right answers for these things. On number 2, page down here, there we go. Part A, we're going to write a relation which is symmetric with respect to the x-axis. What would a graph that is symmetric with respect to the x-axis look like? If it's symmetric, that means it's kind of like a mirror image, right? Okay, so we'll start there. This is going to be a mirror image over what? Over x. So when I look at it, would it be the same on the left and the right side, or would it be the same on the top and the bottom? Where's my x-axis? Yeah, here's my x-axis, and it's a mirror image over the x-axis. So it's going to be the same on the top as it is on the bottom. So, for example, if I had something like this, what would it look like on the other side? Yeah. That kind of looks like an absolute value, right? Except it's on its side. Could I draw a parabola on its side? Is that a mirror image top and bottom? What about a vertical line? Those could all work, right? Let's look at the parabola for just a second, because I want to figure out how to write this. First of all, is that a function? No. They didn't even ask for a function, did they? They asked for a relation. In fact, if it's symmetric across the x-axis, it can't be a function. If it was a face-up parabola, just like a normal parabola, is that a y equals or an x equals equation? Y equals. So if it's sideways, what do you think that would be? X equals. So I can have x equals y squared. I drew something at first that kind of looked like an absolute value, right? We could have x equals the absolute value of y. That means that no matter whether I put a positive or a negative y in, I'm going to get a positive x back out. How could I write an equation for a vertical line? X equals something, right? I don't know, x equals 2. Sounds good. Those are all examples of things that would have a mirror image over the x-axis. Let's take that idea now and go look at part B. What do they want me to do on part B? Yeah, symmetric to the y-axis only. So this is going to be a mirror image where? Yes, mirror image over y. So give me some things that you know of that would give me mirror images over the y-axis. Quadratic. I could have a parabola like this, right? What else could I have? I could have absolute value.
Y equals X.
Y equals x is going to look like this.
Oh, well, Y equals like 1.
Y equals 1. That would just be a straight horizontal line, right? I agree that that one is the same on both the left and the right. Is this an exhaustive list of all possibilities? No. But we've got at least 3 good examples up here. I know what I'm trying to think of for something that is symmetric about the y-axis. So y equals x squared could work. Y equals the absolute value of x could work. Y equals 1 could work. I'm sure you can come up with more examples than just those three, but that's just kind of a short list to get us started. Part C, a function that is symmetric with respect to the origin. What do I want now? With respect to the origin. That's okay.
Symmetric with 0, 0.
Symmetric with 0, 0. We also call this rotational symmetry. Rotational symmetry is if I spin it 180 degrees, it looks exactly the same.
So could you do a circle?
You could do a circle.
Oh, but it's not a function.
Correct.
You do
X
x equals 0.
equals 0. So let's look at what that looks like. X equals 0 would be a vertical line that goes like this, right? If I take that and I spin it 180 degrees, does it look exactly the same? Yes. Okay, so that would absolutely work. Could I do x equals 1? Let me draw it on here. If I take this and I spin it 180 degrees, will it line up exactly? Take this right here. I want you to imagine that I have a pin right here. If I spin that upside down, what's going to happen to my line? It's going to move over to the negative
I
side.
thought you were just saying the line, not the entire graph.
No, it's about the origin. So this one is kind of like having a pinwheel. It's like sticking a push pin right here and then spinning it about the origin. Does that make more sense?
So could you do
Y equals 0. Let's draw it up here and see if it works. Y equals 0 would be right here. If I take that, I stick a push pin right on the origin, and I spin it 180 degrees. Does it match up? Yes. So that one would work. Can you guys think of anything else that would work like that? Y equals x. Let me draw in y equals x. If I stick a push pin on the origin and I spin it 180 degrees, does it line up? Yes. Y equals x would work. Anything else? I can think of one more that we kind of talked about when we talked about different transformations. Y equals negative x would work. Because y equals negative x would be like that, right? What about this? If I stick a push pin on the origin and I spin it 180 degrees, would it line up exactly?
Yes.
If my art skills were better. What function is that?
Cubic.
Cubic. So y equals x cubed would also work. We could sit here and keep coming up with functions all day, but this is a good one because it's kind of harder to wrap your mind around rather than just mirror images. I want to be able to spin it, so I wanted to come up with a couple more examples, and I love the examples you guys came up with at the beginning. Part D, I want a relation function? No. I want a relation with all types of symmetry. Why do you think it says relation and not function?
So you can have an absolute value or a parabola.
Absolute value and parabolas are functions.
Are they just not one-to-one?
They're not one-to-one, correct? Functions don't have all types of symmetry. They can't have X symmetry, right? I heard somebody say a circle. Because if I have a circle, I'm going to screw this up royally. Does it matter where the center of the circle is?
No.
Let's see. If I move my circle to right here, does that have symmetry about the origin? No. Does this have symmetry about the origin? So does it matter where the center of my circle is? Absolutely it does. Is this symmetric with respect to the x-axis? With respect to the y-axis? Does it have rotational symmetry? So a circle would absolutely work here. Give me an equation for a circle with the center at the origin. X squared plus y squared equals, you can put anything. Give me a number though, because if I actually ask you to write me a relation, it does need to be equal to something, not just r, otherwise you've given me a formula. 4, 9, 16, 37, 112, don't care. Give me a number. How do you guys feel about this one? Better than when you first read it? Okay. What else did you guys want to talk about? Which one? 3C. Absolutely. This is find the inverse and then name domain and range, right? Oh, it just says domain of the inverse. Cool. So finding the inverse function, what do you know inverse means to do? Yep, we're going to switch x and y. So this is going to become x equals 2 to the y minus 3. What is my next goal? To get y by itself. Where is y? It's in the exponent. How do I get the exponent isolated? Yes. So I'm going to rewrite this as a log. What's my base? 2. Log base 2 of x equals y minus 3. How do I isolate y now? Plus 3 on both sides. Does that combine with my x?
No.
Then please make sure x is inside parentheses, because otherwise I can't tell whether it's part of the argument or not. If you just put log base 2x plus 3, I am unclear. So I would have f inverse of x is equal to log base 2 of x plus 3. What would the domain for that be? All the things that I am allowed to use for x. Can I use 0? So does that mean parenthesis or bracket? Parenthesis. 0 to infinity with parentheses. What would the range be?
Why is it 0? Oh, because it's exponent. Or wait, what?
Logarithms, my arguments have to be positive numbers.
Oh, right.
Does that have something to do with the 3?
Does it have something to do with what?
The 3?
For my range? Nope. It is all real numbers. Negative infinity to positive infinity. Because if x is, say, 1/2, what is log base 2 of 1/2? -1. So I can get negative numbers back out from this log. It can have outputs of negatives. If I had log base 2 of 1 over 35. Sorry, 1 over 32. Log base 2 of 1 over 32. -5. -5 plus 3, I'd have a negative output overall. So my range is all reals. After school today, I will have all of my answers, not my work, just my answers for each of these problems. Get in there, check your work against mine or check your answers against mine. Anything that you still don't have a correct answer for, please feel free to ask me about tomorrow. I will post all of my work tomorrow. So if I don't have time to answer your question, if we don't get to it during class, you will still have access to all of my work. Yes, ma'am.
I have a question about the program.
Yes, absolutely. Yes, sir. The domain. So domain is all the things that you're allowed to use for X. What do you know about the argument of a log? Can't be negative. Yep. Since X is my argument. If X was somewhere else, I'd have to ask a different question, but X all by itself is my argument.